So in this problem, we want to write and draw the condensed electron configuration and identify how many unpaired electrons each element has. So in order to do this, we're going to start with magnesium. So the condensed one starts with the closest noble gas. So the way you would do this is you'd look for magnesium on the periodic table, go backwards until we find the previous noble gas, and so we know that it will be neon is the electron core, and then we continue past that. And so in this case, there are 2 electrons in the 3s. Okay, so we'd find that out, 1, 2, 3. So if we want to draw this, we'll use the condensed core of neon, and then there's the 3s, and there are 2 electrons, so there are 0 unpaired. Okay, what about for the next one? In this case, we're going to use Ge, which is germanium. Can't quite see that. So we have germanium here, and so we'll track all the way back to find the closest fully filled noble gas, which in this case is argon. So we'll write that down. Okay, and so after that, what we will do is we'll read past argon, so then we'll fill the 4s too. Yeah, you can kind of see that. So we have the 4s, which has 2 electrons. The next orbitals are the d orbitals. All 3 of the 3 d orbitals are filled, 3d10. And then there are 4p, and there are 2 electrons in here. Okay, remember that these are the 3d, and they are filled after the 4s. And so from here, what we'll do is we'll rewrite this out to determine whether or not there are paired electrons or unpaired electrons. So we have argon. Now these can be written in either order. They are very close in energy. It turns out when the d are filled, they move in front of this. I will accept both. So then we'll have the 5 3d orbitals. 1, 2, 3, 4, 5. We'll put in all of our electrons one at a time in each orbital, and then you go back through and fill them in the reverse direction. Okay? Now we have the 4s, and there are 2 electrons in there. Next comes the 4p orbitals. 1 electron in each orbital until they're all half filled, and so there are 2 unpaired electrons. Okay, the next element of interest is yttrium. Okay, well, let's find that on the periodic table. Turns out it's right here. So we need to find the closest fully filled noble gas, which is going to end up being krypton. So we'll write that in brackets, okay? So from here, after krypton, we're going to fill the 1, 2, 3, 4, 5s, and then the 4d. So there are 2 electrons in the 5s, and in the 4d there is 1 electron, okay? And so in this case, again, either order is acceptable. And so to draw these, we'll have the noble gas core, 5s, and there are 2 electrons. In the 4d, there's 1 electron, okay? So there is 1 unpaired electron in this molecule.